Hello and welcome to the Startup College Business Data Analytics course. And today we are looking at the financial management section, and we begin from the time value of money. Now, time value of money proceeds from the premise that one bird, a bird in hand is equivalent to two in the bush, right? And that's why we say $1 today is worth more than $1 tomorrow. Now, money has a characteristic of losing value as time progresses. This is a phenomenon that we call inflation. For instance, what you could buy with 1,000 shillings in 2013 is not the same as what you will buy with 1,000 shillings in 2023. Definitely, the basket has declined. The basket has shrunk. You'll be able to buy less equipment or less items with 1,000 shillings today than you did 10 or 20 years ago. Now, we incorporate this characteristic of money when doing financial management, because if we do not, we end up ignoring an important concept, and the consequences are that we will come up with decisions that are erroneous. Remember, the main goal of financial management is to increase the value of the company or the value of the shareholders. So if we do not take into consideration the time value of money, we might end up making decisions that lead to a decline in the value. And that is where now the time value of money comes in. Concepts such as present value, future value, discounting, discount rate, number of periods, and so on. That is what we look at in this section. Now, we have a formula for present value. When we say that future value, the value of money in the future is definitely less when you consider it in the present value. Now, we have a formula whereby we can convert a future value into present value so long as we know the discount rate as well as the number of periods. And what is that formula? Manually, we say present value is equals to, now present value, it is the value of that particular cash flow or that particular item at time zero, right now, as the name suggests, present value. So to get the present value, we say future value divided by 1 plus the discount rate power n being the number of periods. So the further the value is in the future, the lower its present value, because time has elapsed. So we say there is an indirect relationship between, or rather an inverse relationship between the period, number of periods, and the present value. The more the number of periods, the less the present value. Secondly, the higher the discount rate, the lower the present value, right? So we see, and this is how they interact in this formula. So we have Excel formulas that have been incorporated in Excel to help us to find these values without necessarily doing it the manual way. Now we have the first value, which is the FV, the future value formula. Now we have several inputs that we input in this formula so as to adequately calculate the future value. And we calculate it as equals, when you open the Excel, you type in equals FV, rate, comma, you write a comma, then NPR. Now NPR, this has been described here. Rate refers to the interest rate per period. NPR is the number of periods, for the investment. For instance, if you are told that these cash flows are going to be received every year for 7 years. Now 7 years is the NPER, number of periods. We have PMT. PMT is the payment made in each period. That is, if any. Now, for instance, using the example I've said, if you are told you are going to receive 1,000 shillings at the end of every year, there your PMT is 1,000 shillings. The next input in the formula is PV. PV stands for present value. We are saying it is optional because okay, the present value or the initial investment amount, if omitted, it is assumed to be 0. That's why we are saying it is optional. Remember, you don't always have to have the present value. For instance, you can be told this investment will give you 1,000 shillings at the end of every year, meaning you're not getting anything currently at time 0. And if you're not getting anything, then we input it 0 here, or we leave it blank. We have type, which is also optional. Type, we say this parameter determines whether payments are due at the beginning or end of each period, 0 or 1 respectively. If omitted, it is assumed to be 0. So we have different types of cash flows. Cash flows are either at the beginning of the period or at the end of the period. So if you are going to get the payments at the beginning of the period, that means we pay, we are going to type in 1. If it's at the end of the period, it's 0. You can type in 0 or leave it blank. We are going to see it practically. So if you have this formula, FV equals FV, open brackets, 0.06, 5, minus 100, 0. We are saying that this calculates the future value of an investment with an initial payment of $1,000, an interest rate of 6%, and a duration of 5%. So where you have minus 5, here minus 1,000, we are referring to the fact that we are the ones who are paying. It is minus since it's an expense to us. If it was plus, it means we are receiving that 1,000. Let's move on to the next formula. Present value formula. Here we have almost similar inputs because we type in equals PV, open brackets, rate, NPR, PMT, FV, type. Rate refers to the same interest rate per period. And then remember, another concept that you need to take note of is that when you're talking about the rate, right? Let's say when you're talking about the rate here, you need to know what periods you're dealing with. If you're given the annual discount rate, yet the payments are made every month, you need to convert it into monthly interest rate by simply saying that annual rate divided by 12. If the discount period is twice a year or semi-annual, then we say over 2. The annual rate divided by 2 since it's semi-annual. If it's per quarter, over 4 to get the quarterly rate. Then we have the NPV, the NPER, the number of periods, as we said. So if you are told that the cash flows we are going to be received every month, for instance, every month for 7 years, then you need to get the number of periods as 7 times 12, because every period is consisting of a month. So if you have 7 years and you're told that they are being discounted monthly, you convert it into months. Then we have PMT, payment to be received every period. So if you're told you're going to receive 600 shillings per month, that's the value that you use. We have future value. The future value or the amount to be received at the end of the investment. If omitted, it is assumed to be 0. So if you have cash flows of, let's say, 600 shillings every month, and you are told that at the end of the 7th year, you're also going to receive a bulk payment of 100,000 shillings, for example. That is the future value. But most often, you find that you do not get a future value, and that's why we are saying it is optional, and it is assumed, it is omitted if it's assumed to be 0. Type again, this is whether it is the payments are due at the beginning or the end of the period. 0 referring to end of the period, 1 referring to the beginning of the period. So an example, when you type in equals PV 0.05 10,000, it calculates the present value of 10,000, which is going to be received in 10 years with an assumed interest rate of 5. Now in this example, we are assuming that there are no periodic payments. Here PMT is 0, right? That's why we type in 0. And another thing to note here, the future value is positive because we are going to receive the money. It is not us who are going to pay, right? Move on. Then you have another formula, the NPV formula. Now, you know, in the manual way, we have to calculate cash flows of every year, get the discounting factor for every year, multiply the cash flow for every year by the discounting factor, and then sum these factors to get the present value, the NPV. But now Excel has come in and has made it simpler for us, and we have a simple formula that you can just type in and get your NPV in one fell swoop. So NPV formula calculates the present value of a series of cash flows, both positive and negative, discounted at a constant interest rate. The formula is as follows. So you write NPV, open brackets, write the discount rate first. So if it is 8%, 9%, whatever it is first. Then the value for this is usually the initial value for second, this is the value for the first year, second year, third year, and so forth. So example, NPV equals NPV, open bracket 0.1 minus 1,300, 400, 500, 600, and so on. We are saying it calculates the net present value of a series of cash flows with a discount rate of 10%. So that covers the theoretical part. Now we move on and let's check out examples, simple examples in Excel. Now I open up this Excel and we have some sample questions that we can use to practice the formulas. So the first one, we are told, calculate the present value of an annuity with the following values. So payments, we have 6,500. Number of periods, 6. Discount rate, 8%. You are required to calculate the present value. Now, we come here to this cell. We type in equals present value, open brackets. The rate we are given as 8%. We click there. Number of periods, we are told it's 6. PMT, we have 6,500. This value we are paying, so we need it in negative. So write negative, then click on B2. We are told future value is empty. We don't have a future value. We do not have the type is at the end of the period. So we can leave those blank. Close the brackets, hit enter. So the present value of this annuity is $30,048.72, right? It's as simple as that. We have just done equals PV, B4, B3. We just reuse the referencing that we learned earlier, right? Let us move to the second question. We are asked, calculate the future value of an annuity with the following values. Payment, 5,900. Number of periods, 7. Discount rate, 9%. Future value, that's what you're supposed to calculate. So we open the formula with equals, open brackets, equals FV, open brackets, the rate 9%, click on it, comma, number of periods, we have 7. Payments minus the value given there, close brackets, hit enter. The future value is $54,282.56. It's as simple as that. You can try it out. Moving on to number 3, we are told you are evaluating an investment opportunity that promises to provide $10,000 at the end of 5 years. If the present value of the investment is $6,210, what is the discount rate applied? Here, we are going to use the formula rate. So let us see how it looks like. Rate equals rate. So the arguments you are supposed to provide is number of periods, PMT, which is the payments, the present value if there, future value if there, type, and so on, right? So the first step is usually to just represent this in a tabular manner. Let us begin with present value. Here we are told present value is 6 to 10. We are told number of periods. Let us write it as that. Let us simplify as that. We are told it's 5. We are told future value is 10,000. Here we don't have payments or PMT, so PMT will be 0 in our formula. And we want to calculate the rate. Let's write discount rate. How do you calculate it? Introduce the formula equals, type in rate, open brackets, number of periods we have there at 5, which is in B18. PMT payments we have it's 0, don't have any payments per period. Present value we have this. So remember, it's going to be negative since we are the ones who are investing. We are paying for this investment, right? So minus B17. Future value, now this is the value that you are going to receive at the end of the 5 years. So it's going to be in positive. Write in B19, close brackets, hit enter. So our discount rate is 10%. Let us increase the decimal points. So it is exactly 10%, right? It's as simple as that. Moving on to the fourth question. You are considering an investment that promises to provide a future value of 100,000. The discount rate used to calculate the present value of this investment is 8%. Given the present value of 65,000, how many discounting periods in brackets years were used in this calculation? Again, here we use the formula number of periods, NPER. Type in equals NPER, which is number of periods, open brackets, and the arguments you are supposed to provide. The good thing with Excel, when you enter a formula and you begin a formula, it's going to show you what arguments you require. And the arguments here that we require the rate, and we have the rate, which is the discount.